Kourtney Chinnery, and I am presently a sophomore at Bridgeway Academy, and I'm in AP Calculus. This is my 6th video to my 8-part series on teaching you different concepts in calculus. So, on this video, I'll be teaching you about definite integrals. The objective of this video is relating indefinite integrals to definite integrals. And the only formula we'll be using for this video is the formula for antiderivatives or integrals, which is x to the n plus 1 over n plus 1. In the first problem, I'll be doing an indefinite integral to follow up just to refresh. And then on the second example, I'll be doing a definite integral so that you can learn how to relate indefinite integrals to definite integrals. And then on the third example, I'll be teaching you another concept just to refresh on definite integrals that we will get to later. So, for example A, we have find the integral of x squared dx. Now we'll be using this formula, x to the n plus 1 over n plus 1, which gives us x cubed over 3 plus c. Now, I know you may be wondering how I got this answer. So, remember that once we take the integral, we remove the integral sign, and we no longer write dx, which means taking the derivative in respect to x, but we add a constant, which is c. So we took the derivative, x cubed over 3, removed the integral sign, no longer wrote dx, and add a constant. So that is our answer to problem number 1, or example A. So for example B, we will write, we have find the integral of x squared dx with limits 3 to 1. And the difference between definite integrals and indefinite integrals is that we have limits on the top and the bottom of the integral sign, and that it's a little bit different in the process to find the answer. So, x squared dx, we use the same formula, x to the n plus 1 over n plus 1. So we have x cubed over 3, and we no longer write the integral sign or the dx, but we write a vertical line with the limits on the top and the bottom of the line. So we write 3 and 1. When finding the answer to the equation, we have 3, so we plug 3 in for x, 3 cubed over 3, and we're going to subtract the answer when we plug in 1, which is 1 cubed over 3. So that comes out to be 3 times 3 equals 9, 9 times 3 equals 27. We get 27 over 3 minus 1 over 3, which gives us 26 over 3, or 8 2/3. The answer to example B, which is the definite integral of x squared dx with limits of 3 and 1, are 26 over 3, or 8 2/3. Okay, for the last example, a new concept that we'll be introducing is that if the upper and lower boundaries are equal to each other, then the answer is 0. So for this problem, we have the limits of 2 and 2, 3x cubed dx. For this problem, we'll be using the same formula that we used throughout the whole rest of the video with the last 2 examples for the indefinite integral and the definite integral. So this is another definite integral, since we have limits of 2 and 2. For the formula x to the n plus 1 over n plus 1, first we have to bring the 3 out, which is the coefficient. So we have 3, and then we have the limit 2, x cubed dx. Now we find the antiderivative. We have 3x to the 4th over 4. And then we no longer write dx, but we have our vertical line and both of our 2's. For this problem, we removed the integral sign and we removed the dx once we solved for integration. So now for the last part of the problem, we have to just plug in our 2's. 3 times 2 to the 4th over 4 minus 3 times 2 to the 4th over 4. And if we subtract both of the same numbers, then we get 0. So that is our equation for solving to prove that if the upper and the lower boundaries of an integration problem are equal, then the answer is 0. So thank you for watching my video, and that is how I learned about definite integrals. Thank you.